Look, what is the concept of uncertainty? Uncertainty means when we are using the operators, the smallest value which the operators can beat, that will lead to, like, we are not certain of the answer. Say, if we are using a meter rule or a meter scale, and we want to measure, example, 10 centimeter by using a meter rule. So we measure 10 centimeter by using a meter rule. But the problem with a meter rule or a meter scale, because the smallest value on a meter rule is 0.1. So maybe when we measure 10 centimeter, so when we measure 10 centimeter, maybe the value might be 9.9 because the smallest value is 0.1 difference more or 0.1 difference less. So we measure 10 centimeter, but what is the possibility? Maybe the value is not 10, value might be 9.9 or the value might be 10.1. So how much difference is there from the standard value? How much more or less? So how much is the uncertainty in this 10 centimeter? The possibility is that it might have zero point 0.1 more or it might have zero point 0.1 less. So this 0.1 more or zero point 0.1 less, what we call this part, we call that as uncertainty. So uncertainty mainly arises due to the operators or the instrument which we are using for our calculation. So if we have example, using a meter rule or a meter scale, we measure 50 centimeter. So what will be the uncertainty? Like maybe the value is not 50, the value might be, what are the possibility that the value might be 50.1 or the value might be 49.9. So what is the uncertainty? It means it might be 0.1 more or 0.1 less. So the variation from the calculated value or the measured value due to the operators is known as uncertainty. And different operators have different uncertainties. Like example, if you have a meter scale or a meter rule, so if you have a meter rule or a meter scale, what will the uncertainty? It will be 0.1 centimeter. If we have a vernier caliper, so the uncertainty is 0.01 centimeter. And if we have a micrometer, screw gauge, the uncertainty is 0.01 millimeter, or we can also say so 0.001 centimeter. So these are the uncertainties for the measuring instruments which we normally use to measure the length. So which is the most accurate apparatus or instrument to measure the length? Meter rule, vernier caliper, or micrometer?
I think micrometer.
Micrometer, because the micrometer is having the smallest uncertainty.
Oh, yes.
So the variation from the measured value will be smaller. So if the instrument is having a greater uncertainty, than the variation from the measured value, the chances there more, so it won't be accurate. So how to calculate the percentage uncertainty? So if you want to calculate the percentage uncertainty is uncertainty divided by the value recorded multiplied by 100. So example, if I say we measure length of the object was 10 centimeter long by using a meter rule, so uncertainty is 0.1. So what is the percentage uncertainty here? Percentage uncertainty is uncertainty, so 0.1 divided by 10 multiplied by 100. So when we simplify this, so the uncertainty will be 1, percentage uncertainty will be 1%.
Fine.
Is it clear?
Yes, sir. Clear.
So uncertainty, percentage uncertainty is the uncertainty divided by the value which we record multiplied by 100.
100. Right.
Then uncertainty, like we have to calculate when sometimes the quantities are added, sometimes quantities are subtracted, sometimes quantities are multiplied or divided, sometimes there is an exponent of power, and sometimes we multiply and divide by a constant. So how we can work out the uncertainties in that case? So example, the first one is adding or subtracting. if there is an addition of the quantities or if there is a subtraction of the quantities, how to get the uncertainty? Uncertainty is always added. Like example, if I say first for addition of the quantity, we measure first length. The first length example 10 centimeter was there, and the uncertainty because we use a meter rule, so it is 10 plus minus 0.1. And we measured length too, say it was 5, uncertainty is 0.1 centimeter. And the question is calculate the uncertainty in measurement of the length L, which is a sum of L1 plus L2. So we want to find the uncertainty in length, which is given by a formula L1 plus L2. Like when L1 is added to L2, we get the L. So first, what is L1? L1 is 10. What about L2? It is 5. So it is 10 plus 5. So 10 plus 5 is equal to 15. But what about the uncertainty? Uncertainty always add. So what is the uncertainty in L1? It is 0.1. And what is the uncertainty in L2? It is also 0.1. So what will be the uncertainty, the total uncertainty in measurement of the length? So that will be equal to 0.2 centimeter. So uncertainty adds up when we are finding the uncertainty for a quantity which we get by addition of the two quantities or more quantities. If there is another quantity added, so we'll add its uncertainty as well. But the condition is that they should have the same units. If their units are not same, then we cannot add them, their uncertainties. They should have the same unit to get the sum of the two uncertainties. Is it clear how to get the result of a
Yes, sir.
quantity?
Yeah.
Same thing if I say, we want to find the change in the length. So change in length here, example L1 minus L2. So L1 is 10 and L2 is 5. So L1 minus L2 is equals to 5. But what about the uncertainties? As I mentioned, uncertainty always add. So uncertainty in L1 was 0.1 and uncertainty in L2 is also 0.1. So what is the total uncertainty in L1 minus L2? So that is 0.2 centimeter. So even though quantities, we get the change in length by subtraction of the two quantities, but to find the uncertainty, we always add. So even quantities are subtracted, quantities are added, but to get the uncertainty, we always add. Is it clear?
Yes, sir. Yeah.
Same way, if another example of addition and subtraction, like, but this one I want you to solve. Say we measure T1 temperature, which was 30, and the temperature uncertainty is 0.5. And we measure T2, say it was 50. And what is the uncertainty in?
There's 0.5.
Uncertainty of each is 0.5. But if I say, what is the uncertainty in T, which is given by a formula T1 plus T2? So what is
We will add
T1?
that.
Yeah, so 30 plus 50, so that is 80. But what about
80.
uncertainty? What will the total uncertainty in T?
That will be 1. Sir, 1.
So it
We will
will
add
be,
both.
yeah, we'll add both. And same thing if I say we want the uncertainty in temperature change, which is given by a formula T2 minus T1. So final is 50 and the initial is 30. So T2 minus T1 is 20. But what about the uncertainty? Uncertainty always add, even quantities are
And we
subtracted.
will
So
add.
again, it will be 1.
Yeah.
So in this case, the uncertainty will be equal to 1.
1.
Then, if we are multiplying or divide the quantities, like if we are finding a quantity which we get by addition or multiplication or division. So in that case, we cannot add, we will add the uncertainty, but we will not add directly the uncertainties, we'll add the percentage uncertainties. I will give an example. Say we use a voltmeter to measure the voltage and the uncertainty say 0.1 volts. And we use an ammeter, we measure a current say 2 ampere and uncertainty is 0.5. Example. So we want to find resistance. Or first we'll do with a simple example. Say we want to find power. Power is a product of voltage and current. So voltage is how much 3 and the current is how much 2. So 3 multiplied by 2, that is 6. We get the power. But what about the uncertainty? Because these two quantities are multiplied, so when quantities are multiplied, what we do, we first find the percentage uncertainty and add. Because if I add them directly, it does not make sense. Like 0.1 volts plus 0.5 ampere does not give any result because they are different units. As I mentioned in the beginning, when we want to get the uncertainty, we always add to get the final uncertainty, but the condition is that they should have the same units. So they cannot have the same unit, right? They don't have the same unit. So what we can work out, we'll work out the percentage uncertainty in voltage. So how to work out the percentage uncertainty in voltage? Zero uncertainty, which is 0.1, divided by value recorded multiplied by 100. What's the answer? 0.1 into 100. So it will be 10 divided by 3, which is equals to 3.33%. So the uncertainty in the voltage is 3.33%. Then what about the percentage uncertainty in current? So that is equals to uncertainty 0.5 divided by value recorded multiplied by 100. So it will be 50 divided by 2. It will be 25%, very high uncertainty. So now we have the uncertainty in percentage for voltage. It is 3.33% and for current it is 25%. So what is the total uncertainty? 3.33 plus 25, so it will be 28.3%. And what is 28.3% of 6? Like 28.3 multiplied by 6 divided
28.3
multiplied by 6 divided by 100. So it will be
it's 1.698.
Yeah, so I can say 1.7. So power is equals to 6 plus minus 1.7 watts. So we get the uncertainty in power, and that uncertainty, how we get the uncertainty, it's by addition, but because the two quantities are not having the same units, that's why we first calculate the percentage uncertainty, and from the percentage uncertainty we work out the total uncertainty in our answer. Is it clear?
Yes, sir. Clear.
Same way, if the quantities are divided, like example, we have resistance, which is a ratio between voltage and current. So voltage is 3 and the current is 2, so 3 divided by 2, that will give us 1.5. But what about uncertainty? So uncertainty, because we already worked out the uncertainty, voltage was 3.33 and the current was 25. So total uncertainty was 28.3%, 33%. And then 28.33 percent of 1.5. So 28.33 multiplied by 1.5 divided by 100, which will be equal to 0.42. So it will be 1.5 plus minus 0.4. Like always write the same number of significant figures which are given for quantity, same number for uncertainty. So 0.42 is there, that's why I write 0.4, and the unit of the resistance is ohms. So this is the uncertainty in resistance, which is 0.4 ohm. So when two quantities are multiplied or divided, first, what will be our first step? We find the percentage uncertainty, and from the percentage uncertainty, we work out the total uncertainty in the value.
Yes.
Then we may have an exponent. The power is there. Like some of the quantities, they have power. How to work out uncertainty for these type of those. Like example, we measure, say, volume. volume of sphere is 4 by 3 pi r cube. And we may, using a meter, using a micrometer, we measure the radius, say it was 2.50 plus minus 0.01, and then millimeter. So first we will get the quantity. How to calculate the quantity? Volume is 4 by 3 pi r cube. So V equals to 4 multiplied by pi, which is 3.14 multiplied by radius 2.50 cube, and that is divided by 3. What's the answer for this?
Divide by
3.
3.
The whole answer, numerator
So
divided by
9.395.
9.395.
9.4 we can.
Okay, 9.395 or 9.40. Okay. Now this is a volume. We got the volume, but we need the uncertainty. So what we'll do? First, we'll find the percentage uncertainty in R. Okay. Like what will the percentage uncertainty in R? So percentage uncertainty in R is 0.01 divided by value recorded multiplied by 100. What's the answer for percentage uncertainty in value of R? So it will be 1 divided by 2.5. What's the answer for 1 by divided by 2.5?
So 0.4.
So 0.4. So 0.4% is the uncertainty in R. But here we don't, volume is not equal to R, volume is equals to 4 by 3 pi R cube. 4 is constant, 3 is constant, pi is constant, so means the main uncertainty is due to R. So what will happen if the uncertainty in R is 0.4, what will the uncertainty in R cube? So it will be, what power is there? So it will be multiplied. So it will be 3 multiplied by 0.4%. So 3 into 0.4%, it will be 1.2%. Like it will become 3 times the percentage uncertainty of R. So if power was 2, then it will become twice. If power is 4, then it will become 4 times. Power is 5, then it will become 5 times. So what power is there? The percentage and uncertainty multiplied by that factor. So it will become 1.2%. So it means the uncertainty in R cube is 1.2%. So it means the uncertainty in volume will also be 1.2% because rest all of them does not have uncertainties and they are the constant number. We are not measuring them. We are not measuring 4. We are not measuring 3. We are not measuring pi. That's why they don't
They're
have
only
any.
measuring radius.
Yeah, we are only measuring the radius. That's why the uncertainty is only in the radius. So the total uncertainty in R cube will be same as the uncertainty in volume. So we can say volume is equals to 9.395 plus minus 1.2%. So what is the 1.2% of 9.395? So 9.395 multiplied by 2, multiplied by 1.2 divided by 100.
Point 11274.
How much? Can you repeat?
1 minute, I'm writing. Yes, 0.1127.
Okay. So because I'm using 4 decimal places, so 3 decimal places, so 0.11. 2 I will 27, so I will make it 0.113. So that is, and the unit is millimeter cube. Is it clear, this one? Uncertainty
I have
for the
doubt
exponent.
for this volume, this one.
What?
That how we calculate the uncertainty of what? It's same as the R cube, right?
Yeah, because only R cube is involved here.
Okay.
But what if there were 2 quantities? Like example, we are measuring the volume of a cylinder so if we are measuring the volume of the cylinder, volume of the cylinder is pi r square h. So we don't have to measure pi, pi is fixed. We have r square and we have h. So example, we measure r, say it was 3 plus minus 0.1 centimeter, and we measure h, the height, say it was 5 and plus minus 0.1 centimeter. Now what we have to do first, we have to find the volume. So volume is 4 by pi r square h, volume of the cylinder. So pi is 3.14, radius is 3 square multiplied by h is 5. What's the answer for this? 3.14 into 3 square into 5. What's the final answer?
It's 141.39.
So it is
141.39.
okay.
140.
141.39, so 141.4 example.
Yes, yes.
And centimeter cube. But now we need, now what we need the uncertainties. So to get the uncertainty, to total uncertainty in volume, so we should know the percentage uncertainty in R square, and we should know the percentage uncertainty in H, and we will add the total percentage to get the percentage uncertainty in volume. So what is the percentage uncertainty in?
Is equal to smallest value over value recorded method. Means
So
for the
percentage
radius,
uncertainty in R, the smallest value 0.1 divided by value
0.1
recorded to
divided.
100.
Yes.
So what is the answer? It will be 10 divided by, so 3.33%. But because it is R squared, so this is a percentage uncertainty in R. What is the percent? Yeah, multiplied by 2, so it will be 6.66%. That is the percentage uncertainty in R square. And then percentage uncertainty in H, the smallest value divided by value recorded will be 100. So it will be 2%. Now we need the percentage uncertainty in volume. So how do we get the volume? We have the pi, we should have R square and H. Pi is constant, pi does not have any uncertainty, it's a fixed number. R square is having uncertainty, how much? 6.66%, plus H is having 2%. So what is the total uncertainty?
It will be 8.66.
8.66%. So percentage uncertainty will be equal to 8.66%. Now, what is the 8.66% of this? Like the volume we already calculated, which was 141.4 plus minus 8.66%.
So it will be 12.24.
So 141.4 plus minus 12.24. Or because one decimal place, so I'm using a one decimal place, and that the unit will be centimeter cube. Is it clear that how we work out the uncertainty?
Yes, sir. Clear. 141. Yes, sir. Clear.
Okay. Then the last one, the concept of uncertainty, multiplying or dividing by a constant. Like sometimes what happens, the values might be multiplied or divided by certain constant numbers. So how the things will change? Example, normally we calculate the time period. So how we do, like when we experiment is there calculating a time period of a pendulum. So we don't record the time for one vibration. We allow it to swing so it will move and return. So we normally calculate the time for 10 vibrations. So if we calculate the time for 10 vibrations and say it was 14.7. So 14.7 is a time for 10 vibrations. and we use a stopwatch or a stop clock. Normally, the uncertainty of the stop clock or a stopwatch depends on the human reaction time rather than the smallest value which stopwatch can read, because stopwatch can read like 0.01 second, but we cannot stop within that interval, so uncertainty will not be equal to 0.01. It will be equal to the reaction time of a person. So example, we record the time for 10 vibration, it was 14.7 seconds with the uncertainty or a reaction time of 0.2 seconds. If we need the uncertainty in time, so what will be the uncertainty, or if we need the time for one vibration, because this is the time for 10 vibrations, so to get the time for one vibration, we'll divide by 10, so it will become 1.47. And same thing, the uncertainty also will also be divided by 10, so it will become 0.02 second. Percentage uncertainty will not change. Only thing what change is the value. The percentage uncertainty will change here as well, because the value recorded will change.
Change. Right.
So same thing, another multiplying or dividing by a constant does not change the percentage uncertainty will remain same, only the uncertainty will change, because percentage uncertainty is the uncertainty divided by value recorded multiplied by 100, and same thing, percentage uncertainty is the uncertainty which is smallest value divided by value recorded into 100. So when you solve both of them, we'll get the same percentage. So percentage uncertainty does not change. The only thing which changes is the uncertainty and the value which we record.
The value of the uncertainty.
Yeah, right. Value of the uncertainty. So is it clear?
Yes, sir. Here we don't have to do a lot of workout. Only we have to change this.
Yeah.
The values. Okay.
Values.
Okay, sir. Clear.
So this was about uncertainties. Like, and then sometime we have a group data, how we work out the uncertainty of a group data. One is called full range, another one is a half range. So the formula to calculate the uncertainty of a group data is a maximum minus minimum divided by 2. And if you want to find the percentage uncertainty, the formula is uncertainty divided by the mean or average. This is for group data. Group data means like we have a lot of numbers together, like set of values are there. And remember, we have to discard the anomalous result. Don't forget to do this, like discard the wrong values. What does it mean? Like example, if I say student is performing an experiment to find the acceleration due to gravity, and student got the answer 10, then student got the answer 4, student got the answer 11, student got the answer 9, and student got the answer 8.5. So which value appear to be wrong in anomalous from this set of result? 10, 4, 4. So 4 will discard, will not include. Now, if we want uncertainty, to get the uncertainty, what is the formula? Maximum minus minimum divided by 2. So what is the maximum value? The maximum value is 11, minimum value is 8.5, and then divided by 2. This is called half range. So 11 minus 8.5, that is
2.5.
So 3.5 divided by 2. 2.5, sorry, divided by 2. Yeah, 2.5. So 2.5 divided by 2, 1.25 will be the uncertainty. And what about the percentage uncertainty? Because to get the percentage uncertainty divided by mean into 100. So how to get the mean or average? Again, we discard the random or anomalous result. So it is 10 plus 11 plus 9 plus 8.5, and then that is divided by 4.
The total number of.
Yeah. So because 4
So
values are there, 4 values we include.
9.
38.5 divided by 4.
It will be 9.625.
So it is 9.62.
Yeah, so you can do 9.63.
Yeah, 9.63. So 9.63 is the mean. Now, how to get the percentage uncertainty? So the percentage uncertainty is uncertainty, which is 1.25 divided by value recorded 9.63 into 100. What's the answer?
It's 12.98. Approximately 13.
So 13%. So 13% is the percentage uncertainty of this
This
experiment.
experiment. Yes.
So this was all about the uncertainties. Then there is another thing which you have to calculate is a percentage difference. Like there's an uncertainty and then there is a percentage difference. So how we can calculate the percentage difference?
So I think it's maximum minus minimum divide on mean.
Yes.
Multiply by 100.
Percentage difference, it depends on what is given to you. Like if the standard value is not given. If the standard value, the fixed value is not given. Like we don't know which one is the standard. Then the formula to calculate the percentage difference is equals to maximum minus minimum divided by mean average into 100. That's the formula. But if standard value is given, then what we do, the percentage difference is equals to standard value minus the calculated value, or it can be vice versa because we need a positive answer. So standard minus calculated value divided by standard value. The denominator should be standard into 100. And how we can compare our experiment, whether it is
So I can't
accurate
understand
or
the standard word. So
like
what is the standard?
standard. Like example, if you did the experiment, you're finding the value of a gravity, you get answer 8. Like the previous results, we were having a 10, we were having 4, we were having 11, and we were having 8.5 and 9 was there. So we discarded 4, and when we work out the average was 9.65 or 9.63, I guess.
9.6.
Yeah. So 9.63 is our calculated value for acceleration due to gravity. This is what we calculate. But what is the standard value? What is the
10.
standard? 9.81 is the standard value of acceleration due to gravity. So if we want to calculate the percentage difference, so how we calculate a percentage difference? So it will be a standard value minus the calculated value divided by the standard value to 100. So we'll get the percentage difference. What's the answer
Right.
for this? 9.81 minus 9.63 divided by
Divided by 9.6.
divided by 9.81. 9.81 is the standard, so we always divide with the standard.
So it's 1.834.
1.834 or 1.83 percentage. So percentage difference is 1.83. And when we calculated the percentage uncertainty, if you remember the last, how much was the percentage uncertainty when we calculated?
For the last question.
Yeah,
Yes, 13 was
how much it was? 13%.
Yes, 13%.
13%. So how we know whether our experiment is correct or inaccurate? So we'll compare the percentage difference with percentage uncertainty.
Okay.
So if our percentage uncertainty is more than the percentage difference, it means the experiment is not accurate. And opposite will happen if the percentage difference is more than the percentage uncertainty. It means like if the percentage difference uncertainty is more than percentage difference, because look, whether the experiment is accurate or no, so the percentage uncertainty is how much? It is 13%, means our answer might be 13% more or 13% less than this value, which we calculated 9.63. So if what is the 13% more? 13% of 9.63. How much is 13% of 9.63? Can you work out?
1 minute. 13%. But it's 1.25.
So 1.25. So 1.25 more. So 1.25 more means it might, the maximum value which we can have, that was 10.8 approximately. And the minimum value which we can have, it is about 8.4 meter per second.
Right.
So these are the values approximately. These are the values which might have 8.4 and 10.8. And our answer vary from the standard value, because the standard value is 9.8. So our answer only vary 1.83% from the standard value. So 1.83, which is a very small difference from the standard. So it means our this what we get, like our range will be there within this standard value. So if the percentage uncertainty is like percentage uncertainty is less, and the percentage here our experiment variation is there, it varies from 10.8 to 8.4. Okay, like these are the values it might get. And the percentage difference, our difference from the standard values is small, like we have only like 1.83% difference. So maybe our value is like 1.83 less or 1.83 more. So it means our experiment is accurate.
That's good.
But if the percentage difference is high and the percentage uncertainty is small, it means the experiment is not accurate. I'll do examples, you will understand. Is it clear, this part?
Yes. Actually, I have a doubt that if the percentage difference is more than uncertainty, so it is accurate.
It is not accurate. Percentage difference more, not accurate.
Fine. But if it is less than uncertainty, means it's accurate.
Accurate.
Fine.